Hello. Said me, please. Are you listening me? Tell me. Somebody please tell me that are you listening me?
Yes, I can hear you.
Okay, thank you very much. So, let's continue our exercises. I know that some of them were in the Dean office, and in the Dean office you are received a collection of the tasks. We have discussed with your lecturer about our program, and we have solved that we will be following this collection of tasks. Namely, as concerned the program on the geometry, we have used a program from this collector of tasks with the name the analytical geometry. Unfortunately, this program is in Russian language only. We will try to translate this program to the English, but simply understand all tasks will be from this problem book. Unfortunately, this problem book only in Russian language, but there are electronic version of this problem book. I will send you after your request. And some task very simple to understand. Yes, it's concerned for matrix calculations, for instance. But some problems are required of translation. We will translate it in English and send you the correspondent text. But of course, you can use the online translator as Google, for instance, for translate the text of the problem. So, the name of this book in the Russian «Сборник задач по аналитической геометрии и линейной алгебре». I tried to translate to the English problem book on the analytical geometry and linear algebra, authored by Beklemishev, Petrovich, and Chubarov. This book. I will send you the electronic version. And from your program that you are received in the Dean office, or if you does not receive this program, I will send you also by email. We have following the first part of this program. The first part of this program is matrix and determinants of the second and third order, and system of linear equations and Cramer rules. We have begun last time to investigate the matrix operation and determinant. And last time we have defined the determinant of the second order. Determinant of the second order. A sub 1, A sub 1, 2, A sub 2, 1, A sub 2, 2 equals A1, 1 times A2, 2 minus A2, 1 times A1, 2. The simple rule. The product of the terms on the main diagonal minus the product term on the co-diagonal, the main co-diagonal. So Now we will consider the determinant of the second order. Determinant of the third order. Third order. Ики, помогите, пожалуйста. Повесить. So, in this case, we will consider the square matrix of the third order. Namely, let's A equals A11, A12, A13, A21, A22, A23, A31, A32, A33. Square matrix. 3 columns and 3 rows. Then determinant A equals, by definition, let's rewrite A sub 1 sub 1 1 1 A1 2 A1 3 A21 A22 A23 A31 A32 A33 equals. To calculate this determinant, we have used so-named triangle rules. Namely, first term, product of the first term of the determinant is the product of the terms located in the main diagonal, at the main diagonal. Namely, A sub 1 1 times A sub 2 2 times A 3 3. Then consider the triangle like this. Plus A sub 1 3 times A sub 3 2 times A sub 2 1 plus consider another one triangle. The base of these triangles are parallel to the main diagonal. Main diagonal, namely plus A sub 1 A sub 2 3 times A sub 3 1. So when we have calculated the determinant of third order, we have 3 terms, 3 positive terms, the sum of the 3 terms. Then we have the minus of the 3 terms. Each of them is a product. Minus product of the terms located in the co-diagonal, the main co-diagonal. Minus A sub 3 1 times A sub 3 1 times A2 2. A2 2. Minus. Let's consider the next triangle, the base of which is parallel to the codiagonal minus A sub 1, 1 times A sub 3, 2 times A sub 1, 3. And the last term, this triangle, for the product terms with in this triangle, the base of it is parallel to the co-diagonal. Minus A sub 3, 3 times A sub 2, 1 times A sub 1, 2. So this formula we can consider as a definition of the determinant of the third order. This formula we will consider as a definition of the determinant of the third order. So let's try to calculate some determinant. Let's consider the following example. One minus 2, 3, minus 4, 5, minus 6, 7, minus 8, 10. Determinant equals. Let's calculate. The product of the term located in the main diagonal. 1 times 5 times 10 plus the product of these terms. 3 times minus 4 times minus 8. Plus the product of these terms. Plus minus 2 times minus 6 times 7. Then the terms with sign minus. Minus product of the terms on the codiagonal, the main codiagonal. Minus 3 times 5 times 7. Minus consider this triangle. 10 times minus 2 times minus 4 minus consider this triangle. 1 times minus 6 times minus 8 equals. Let's calculate. 50 plus 96 plus 72 minus. Yes, of course. Yes, much more easy to use the properties of the determinant. But due to program, you have to know this difficult formula. Of course, when we have calculated the determinant, we have not used this formula. It's not convenient. It's only for knowledge. Minus. So, minus 4. No. This one. Minus 2 times minus 6, it's 12. 12 times 7, 82. Yeah. Да. Так, теперь now minus 105 minus 80 and minus 48. What we have? Minus 55 plus 4 plus 88. So 54 minus 55 equals minus 3. So, of course, it's not convenient. Later we will know the more simple rules of calculations this determinant. Let's continue. There's another one example. Yes?
Can you see this?
Could you please repeat slowly because the volume of the sound will too slow. Please repeat.
Now I wrote for you a formula in chat. Can you check this?
Please repeat.
I wrote a formula in chat. Can you check this? I think it's easier.
Не понял я.
В чате он написал формулу.
Yes, of course. I see the formula from the chart, but it's the next step of our exercise. Of course, much more easy. Of course, you are right. So it's the initial formula. I repeat that practically nobody doesn't calculate it by this formula because it's very difficult. So, usually to calculate the determinants, we have used the rules of the determinants connected with the elementary transformations under the rows or columns of the matrix. Namely, properties of the determinant. First of them, if A power T transpose matrix, then that determinant transpose matrix A power T equals determinant the initial matrix. The determinant of transpose matrix is equals to the determinant of the initial matrix. Next rules. If all elements of the one row or column is 0, then the determinant is 0. The determinant is 0. For instance, A sub 1, A sub 1, n, etc. A sub n minus 1, 1, etc. A sub n minus 1, n. But the last row is 0. 0, etc. 0. In this case, the determinant is 0. In this case, the determinant is 0. The second example, the second rule. Second, exactly properties. Third properties. If the determinant contains two identical rows or columns, then the determinant is 0. Then the determinant is 0. Yes.
The first word is not determined the matrix.
Yes, you are right. If as a determinant, understand the denotation like this. Matrix, exactly. The determinant is 0. 0. What's other question?
Я подсоединил пользователя, который не с никтовского аккаунта.
I see. For instance, a sub 1 1 etc a sub 1 n a the same sub 1 1 etc a sub 1 n a sub 3 1 a sub 3 n etc n a sub n sub 1 a sub n n equals 0. Because this determinant exactly the matrix determinant of which we are calculated the same rows. The same rows. Example. Example. One, two, three. 1, 2, 3. 5, 6, 7. Determinant. Immediately we have seen that it's 0. Because contains the two identical rows. Example A. Example B. 1, 2, 1, 2, 3. 2, 5, 7, 5. Determinant. Also 0. Also 0. Because it contains the same columns. The same columns. So I see. The next properties. The determinant is not changing if to the all elements of one row add the elements of the another row. Of the another row. This properties is also valid for columns. For instance, A sub 1 1, A sub 1 n, etc. A sub n 1, etc. A sub n n will be equal A sub 1 1, A sub 1 n, A n 1 plus A 1 1, A sub n n plus A sub 1 n. If we add to the elements of one row or column the elements, the corresponding elements of the another row or column, the determinant will be the same. The determinant will be the same. Next properties. If the change the elements of the one row or column to the elements, if the change the elements of the one row column to the elements of the another row or column, then the determinant will change its sign. The determinant will change its the sign. Namely A sub 1 1, for instance, A sub 1 n, etc. A sub n 1, etc. A sub n n. Let's change the elements, replace two rows by its place, namely. In this case, the determinant will change its sign. Equals minus A sub n1, etc. A sub nn. A sub 1 1, A sub 1n. The same valid for the columns. The same will be valid for the columns. The same be valid for the columns. Next properties. If T is upper triangle matrix, namely T sub 1 etc T sub 1n, T sub nn, Tc, all these elements below the main diagonal are 0. Then determinant T equals the product of the elements from the main diagonal. T sub 1 1 times T sub nn. Example. Determinant 1, 2, 3, 0, 4, 5, 0, 0, 6. The determinant of the upper triangle matrix will be equal 1 times 4 times 6, namely 24, namely 24. And I forget example for the previous property. For instance, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's replace the first and third rows. We have minus 7, 8, 9, 4, 5, 6, 1, 2, 3. Or, for instance, change the place of the second column or and third column. 1, 3, 2, 4, 6, 5, 7, 9, 8. Sign minus here. If the case of replacing the places of the columns or rows, the determinant will be changed its sign. Next properties. For instance, if the elements of one rows or columns are product to the same number, exactly, lambda times a sub 1 1 etc, lambda A sub 1n A sub q1 etc A sub 2n etc A sub n1 etc A sub nn. This determinant will be equal lambda times the determinant A sub 1 1 A sub 1n A sub 1n 1 A sub nn. Example. First row 2, 4, 6. Second row 0, 1, 1. Second row 0, 0, 3. This determinant will be equal 2 times 1, 2, 3. 0, 1, 1. 0, 0, 3. And of course, it's equal 2 times 3 equals 6. So, for let's consider the matrix A sub 1 1 A sub 1 2 or 1n sub 1n etc A sub 1 n 1 n sub nn. And consider the element with the index ij. Element with index a sub ij are located on the crossing of the E rows and G columns. E row, J column. Let's define the value M sub ij. The determinant of matrix that we will receive escaping the I row and J column from the initial matrix. Initial matrix is matrix. Namely, A sub 1 1 A sub 1 j minus 1 A sub 1 j plus 1 etc A sub 1 n. A sub I minus 1, 1. A sub I minus 1, J minus 1. A sub I plus 1, I minus 1, J plus 1. A I minus 1, N. Next. I sub I plus 1, 1, etc. A sub I plus 1, J minus 1. A sub I plus 1, J minus plus 1, etc. A sub J plus 1, N, etc. A sub N1, A sub N. Example. Посмотрите, как минор будет по-английски. Минор. Минор. Example. A equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's calculate M sub 1, 2, for instance. What is it?
Minor.
Element with index 1, 2, this one. We have escape first row and escape the second column. What we have? Determinant. Tell me please, somebody. What we have here? The determinant of the matrix, which will be received from the initial by escaping the first row and escaping the second column. What do we have? Four, 6, 7, 9 equals 4 times 9 minus 7 times 6. We will not calculate it. Next. M sub 3, 3. What is it? Tell me, please. For instance, you. Yeah, yes. Yes. 1, 2, 4, 5. Yes, and the last example on this properties, m sub on your choice. On your choice index here. 2, 3? 2, 3. 2, 3. Where is it? It's here. No, not here. 2, 3. We have escaped second row and third column. Yes. 1, 2, 7, 8. Of course, it's equal 1 times 8 minus 7 times 2. Okay. M sub A, M sub ij, so M sub ij, so name minor of the element A sub aj. Next properties. Sometimes this next properties is so named Laplace formula. Laplace formula. It is valid, the formula. The determinant of the matrix of the square matrix of the n order, namely A sub 1, 1, A sub 1, n, A sub n sub n1 etc, A sub n n, can be calculated by the following formula. The sum of the product of the element of the one row of the matrix A to the minors of to the corresponding minors with the sign minus 1 power I plus j, namely A sub I1 times minus 1 power I plus 1 times m sub I1 plus I sub I2 times minus 1 power I plus 2 times m sub I2 plus etc plus A sub in times minus 1 power I plus n times m sub in. Or we can write the same formula for the elements of the column. For the elements of the column. I or A sub 1j times minus 1 power 1 plus j times m sub 1j plus a sub 2j times minus 1 power 2 plus j times m sub 2j plus etc plus n a sub nj times minus 1 n power n plus j times m sub nj. Example. Determinant a sub 1 1, a sub 1 2, a sub 1 3, a sub 2 1, a sub 2 2, a sub 2 2 3, a sub 3 1, a sub 3 2, a sub 3 3 will be equal, for instance, a sub 1 1 times minus 1 power 1 plus 1 on the correspondent minus 1 sub m sub 1 1. M sub 1 1 plus a sub 1 2 times minus 1 power 1 plus 2 times m sub 1 2 plus a sub 1 3 times minus 1 power 1 plus 3 times m sub 1 3. In our case, it will be minus 1 in the power 2 is 1, a sub 1 1, determinant a2 2, a2 3, a3 2, a3 3, minus 1 power 3 is minus 1, minus a sub 1, a sub 1 2 times determinant a 2 1, a 2 3, a 3 1, a 3 3 plus minus 1 in power 4 is 1, a sub 3 sub 1 3 times determinant a 2 1, a 2 2, a 3 1, a 3 2. It's much more convenient formula for calculation of the determinant. It's much more convenient formula for calculation of the determinant. So let's consider some example. I think we'll try to consider examples from this textbook. So Task number 15.2.3. It's a very simple example on the topic of the previous seminars. .2.3. It's required to calculate 2 times matrix 1, 8, 7, minus 15, 1, minus 5, minus 6, 11, minus 5, 24, minus 7, minus 1, minus 1, minus 2, 7, 3. Because it last seminars, I think we can calculate it. Please send me. Exactly, tell me. What's answer? Tell me. Minus 5. 6. 2 times 8. 2 times 8 minus 24. 2 times 7 plus 7. Yes. 2 times minus 15 plus 1. It's the first row. Second row. 1 plus 1 plus 2 times 2 times minus 6 minus 7 and 2 times 11 minus 3. Exactly. Good. Next task. Next task. Uh, 15.5.7. Да.
Я его проигнорирую. Почему? Вот этот вопрос, который выделен семизначным.
I see. Because the last Saturday we discussed with your lecture about sorry. The right question. Why are your lectures about plane geometry and the seminars about analytical geometry? I will answer you the following words. We have discussed with your lecture last Saturday about our program, and we saw that first two lectures will introduction to the planar geometry, but the main aim of our subject is the analytical geometry. But we have solved at the seminars to begin with directly with the analytical geometry, because very soon the lecture will be devoted to the analytical geometry. But the matrix operation is required will be used in the analytical geometry. Namely, in the will we have investigate the condition of the vector of the condition of where the vectors are collinears or the complanars, and many to calculate vector product or scalar product. But introduction lecture on the planar geometry I think also required for remember your knowledge on these topics, only for remember. So, next example, I think will be good this one. Calculate the determinant. $33,547 $33,647. $28,423. $28,523. So, if we will calculate this determinant using the definition, namely 3, 3, 5, 4, 7 times 2, 8, 5, 2, 3 minus 2, 8, 4, 2, 3 times 3, 3, 6, 4, 7. We have received very difficult calculation for oral calculation. But we can use the properties of the determinant. But if you use the properties of the determinant, we can receive let's in memory times the first column 2 minus 1 and add to the second column. In this case, the determinant will be the same. 3, 3, 5, 4, 7, 100. Two, 8, 4, 2, 3, 100. Equals 100 times 3, 3, 5, 4, 7 minus 2, 8, 4, 2, 3 equals times 100 times 5,000 100 24 equals 512,400. Using the properties of the determinant, very easy to calculate this difficult determinant. Next example from the main program. I will try to find the task on the determinant calculation. Yes. The task number 14.7.3. .7.3. 0.3. So to calculate the determinant of the third order, A sub 202. What denotes this number? At the end of this problem book, there are so name of the bank of matrix. So this number denote the number of matrix from the bank of matrix. We have to open the end of the problem book in my edition, it's page 470. And here we have a bank of matrix. Matrix with number 202 is one, two, 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 one, minus two, two, minus two, one. Let's try to calculate this determinant. You are ready? Maybe somebody go to the blackboard and to try to calculate. Who want to try? Maybe you? Are you ready or not? With my aid. With my aid. Maybe you? Let's try. Игорь, посмотрите, как сказать, вычесть.
Сейчас.
Я забыл, вылетает из головы. Вычесть элементов одной строки, элементов другой строки. Только чтобы не завало. So, as you understand, you will use the yes. 202 denote the number of the matrix from the bank of matrix. It's not the index of size of matrix. It's number of matrix from here. Do you see?
Okay.
So name bank of matrix.
Excuse me.
Yes.
In the task, you have the pointer, not the matrix.
You just have the number and to just open
Yes. 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 Number from here. Could you please to write in the detail? In the detail. Your calculation, please write detailedly. Step by step.
Вы можете на экране посмотреть сейчас.
Subtraction. Subtract, okay. Could you please explain me what do you do now?
I want to do this.
The rule of triangles, yes? Yes, okay. 1 times 1 times 1, yes? So you are right, of course, but please write 1,
Yeah. 1 by
1 times 1 times 1 plus 2 times minus 2 times 2 plus 2 times 2. No. You see.
2 minus 2 and minus
Yes, and
2 minus
yes, okay. And minus. So the student using the so-named triangle formula, yes? But of course, this determinant we can calculate much more easy using the properties of the determinant. I think it will be make the next student or oneself. So you have received the result minus 19, yes? Let's try to check your result. This, I don't know the results, but of course in the end of the problem book there are answers. But I will calculate this determinant using the properties of the determinant, namely, let's times all elements, let's times in memory all elements of first row to the 2 and subtract from the elements of the second row. What we have? The determinant will be the same. First row, yes. Да. 1, 2, 2. In memory, times all elements of this row to the 2 and subtract from the corresponding elements of the second row. What we have? 2 minus 1 times 2. 1 minus 2 times 2. And minus 2 minus 2 times 2. So let's try in memory times all elements of the first row to the 2 and subtract it from the second row. 2 minus 1 times 2 minus 2 minus 2 times 2 and 1 minus 2 times 2. What we have? The first row is the same. 1, 2, 2. Second row, 0, minus 3, minus 6, 0, minus 6, minus 3. Let's check. 1 minus 4 minus 3, minus 2 minus 4 minus 6, 1 minus 4 minus 3, minus 2 minus 3. Yes, exactly. Then by formula. Equals 1 times minus 1 power 1 plus 1 times the corresponding minor. Minus 3 minus 6 minus 6 minus 3 equals 9 minus 36 equals minus 27. More simply, of course. But you have no these rules and these rules. It seems there are a mistake here. Yes, I have checked the answer. The right answer, minus 27. So, questions. Который?
Который выделен, я его в рамочку синюю выделил. Ну вот здесь. Там дублируется экран, да?
Да. Yes. So,
Да, я думаю, надо написать конкретное название учебника.
I think the best choice, if I will send the electronic version of this problem book to all students by electronic addresses. I will ask your department about your addresses and will send the electronic version of this book. Unfortunately, this book only in the Russian, but it's very good book. All students of our institute are using this book.
But you can find it in library.
I hope. I don't know. Okay, thank you very much for your time and attention. Any question? Okay, the last sentence from me. I think because you have a collection of tasks, let's try to begin to solve the problem from this collection of tasks. Namely, I will write in the electronic letters what task you have to try to solve. Okay, thank you very much.